Welcome to this tutorial. This is an engineering mechanics tutorial. We are going to look at this question, so I'll give you some time to just go through it. Now, right to the solution, we have a small ring which is of weight or mass 0.25, and I've drawn a free body diagram here just to represent what the question is talking about. Now we have a force of 1.2 newtons, which is in the string, and we are trying to pull it in this direction. Okay, so the frictional force will be in the opposite direction, and frictional force is given by mu times n. Now mu here is the coefficient of friction, and n is the normal force or normal reaction in this case. Now back to the question, we are required to get these two parameters, that is the coefficient of friction and normal reaction. So onto our first step, we are going to resolve upward forces. Now we are going to use this free body diagram in our analysis for the first part to get the normal reaction, or rather to get an equation that will help us get the normal reaction. Now we want to resolve upward forces, so I'll just have to draw this here so that I get the component of this tensional force in the upward direction to be, since we have an angle here theta which is equivalent to 40, so we say the resolution of this force in the upward direction to be sine 40, 1.2 newtons sine 40 degrees. So that is why we've said n, which is in the upward direction, plus 1.2, which is 1.2 sine 40 degrees, which is also in the upward direction. Then we have this weight, or rather the weight of the pin in the downward direction, so that is why we have this negative. Now something to note, we have this g in this case is taken as 9.81 meters per square second. That is the gravitational acceleration. So when you plug in everything, you will get n to be equivalent to 1.7 newtons in two significant figures. Now, so this will form our first equation. So remember, we have gotten the normal reaction and not the units. The units are in newtons. Now let's look at the second part of it, or rather the second equation, to help us get the coefficient of friction between the box and the plane. So what are we going to do here? We are going to resolve horizontal forces considering this free body diagram of the small ring setup. Now I want to resolve this force in the horizontal direction, so remember it will be in the opposite direction. Okay, I think that. So here we shall have 1.2 cos 40 degrees. So this is the component of this tensional force in the horizontal direction. Again, here we have a frictional force that is acting in the opposite direction because this ring is being pulled in on the right. Okay, now we have this equation, 1.2 cos 40 degrees minus F. F here is the frictional force, so mu times n, which we had already calculated here. So when you substitute everything in the equation, we end up with equation 2. So we have to make mu here, that is the coefficient of friction, the subject of the formula. Now look at this. When we make it the subject of the formula, we can be able now to calculate its value. as 0.54761, or rather 0.55 into significant figures. Now note that coefficient of friction does not have units.